I'm Carrie Obedzinski from Times Microwave Systems, and you're watching Real Times, our vlog where we talk about industry trends, new products, and everything coax. Today, we have the infamous Kevin Moyher back with us, our senior product manager, who's going to talk to us today about a new product.
Thanks for having me, Carrie. And yeah, I really
always glad to have you.
Yeah, looking for, really like the opportunity to talk a little bit about this new product line. The XtendedFlex is a coaxial cable that's designed for continuous flexure applications. And I know some of you may ask.
I was going to say, why?
Yeah, why? Why do you need this, right? Well, as 5G continues to get built out, we get closer and closer to ubiquitous coverage, we get lower latencies.
Okay.
It's driving lots of new applications, primarily in industrial and robotics applications that weren't possible before. We're seeing a lot of these robotic arms that are talking to each other. We're seeing robotic arms actually being used for surgery.
Oh, yes.
And these are things that, remote surgery that just weren't possible before. We're seeing a lot of autonomous vehicles. Some of these vehicles are operating in really tough environments, climates and in tough, unsafe situations where you don't really want people to be there. So there's just an explosion. It's a really good time for RF right now, and especially some of these high flex cables. And we have some really good constructions and some really good solutions to provide in this type of market.
So what makes XtendedFlex so flexible and able to withstand all of these flexures?
Well, I like that question. That's a good segue. There's flexible, and then there's ability to perform with flexure. Kind of two different things.
All right.
A flexible cable is something that's got really good bend moments. It's just kind of,
okay.
that can flex very easily. That doesn't necessarily mean it's a cable that's going to hold up with flexure over time.
Okay.
If you want a cable that's going to hold up with flexure over time, there's a lot of that goes into it in terms of the types of materials. Bend moment is part of it. That's part of the construction, but we use, some special plastics. We use in some cases we're using, copper, silver, copper-clad steel strands. Lots of different things we're doing to create this. But you're concerned about work hardening of materials a lot of times. You're worried about degradation and shield ineffectiveness. So there's things that we're doing to compensate for that.
And then how does it maintain this electrical performance through all this motion, this XtendedFlex product?
Well, yeah, one thing is getting the right product for the right application.
Okay.
So we have a portfolio.
So what are some of what's the portfolio?
Yeah,
you beat me to it.
It goes from a very, very tiny cable. And actually, why don't I just, but for the people here, this is what we call
the smallest one?
This is our smallest one, our XF045. We've actually...
XF045.
Yes.
Okay.
We've used this in some certain cables for surgical applications.
Okay.
Very, very fine. As you can imagine, a smaller cable is going to perform well with flexure over time. It's less likely to work hardening materials. You can think of the strains and stresses when you're flexing the cable on the inside radius and the outside radius. So that's diminished with a small cable.
Okay. What's the next one?
The next one is, we have here...
So while you're grabbing that, so you have the ultra flexibility, but these are still low loss cables. How do you create a product that does both?
Well, a lot of it is, in terms of loss, it's cable size.
Okay.
That's still doesn't go away. We're using low loss dielectrics in a lot of cases.
Okay.
Expanded PTFE in most cases. We're doing things to maintain that impedance uniformity with flexure. And we're using a lot of stranded, in a lot of cases, 19-strand center conductors. In some cases, the 19-strand center conductors are copper-clad steel. So it just depends on the application. Going back to the application, this cable here, our XF178,
178
is actually was designed for a drag chain application, and that's where you got a rolling, like something like a forklift type of thing.
Okay.
Where the cable's rolling. And this particular cable survived 7 million flexes in a really tight radius drag chain. Still look really great after 7 million flexes.
So there's applications that we need 7 million flexes.
Yeah.
Wow.
Yeah, we're looking to design cables and supply cables that are going to hold up for the lifetime of the application.
Yeah. So it's one and done. You buy it, it's going to last.
Yeah. And this is a good example of that in terms of a drag chain cable.
And we have the heritage to prove that we're doing it.
We do. Again, that's a really good point. There's 6 cables in this portfolio, XtendedFlex. These are not new designs. These are designs that are proven, that we've developed for certain really rigorous high flex applications over time. And what we're doing is making these available to basically the general public and promoting them as we see this explosion of high flex opportunities in industrial automation, robotics type of market.
And making it available means we're going to actually have some of these products in distribution so that you can get them. But if there's other designs you need, or you need some support from our applications engineers, you can always come direct for support.
Yep. And the thing to keep in mind with high flex is every application is a little different. So, we have a couple of ways we test cables, as we mentioned, the rolling drag chain type of test. We have a method, what we call a tick-tock type of test. We have a couple of mandrels, and we just take the cable and flex it back and forth. Certain angles, certain radius mandrels.
Old school tick-tock.
Yeah, yeah. But that can't capture every application. There's torquing going on, there's twisting, there's different radiuses and things like that. So, if you have a high flex application, we can help you. Come to us. You give us a CAD file of the movement. We can mock it up. We can pick the right construction for that. We can test it. Some of these high flex applications, you really do need to do like a final test and run it through its paces.
And you have mentioned some of the industries that might use this application. You want to run through them again? You said there's medical, industrial robotics. What were some of the other ones?
Well, this cable right here. This cable is our XF174. This actually runs through a soldier's armor.
Oh wow!
From their visor to their weapon, and what their weapon is seeing through the sights, that soldier sees through their visors. The manufacturer of the system, the product, went through a number of evaluated quite a few cables before they evaluated our cable. And they were just blown away.
Those connectors look special too.
Well, these connectors are actually what we call FACRA connectors.
Okay.
And these are more commonly used in a robotics application. So I'm not saying this is not this exact assembly that's used in this.
Well, obviously we wouldn't show that. Yes.
Yeah, but this is the cable. It's a cable that's really designed. It's a very, very rugged cable.
Okay.
And I mentioned copper-clad steel, and this cable actually has copper-clad steel center conductors and copper-clad steel outer conductors.
And I know we're going to be at a lot of trade shows, and you're going to be able to see some of these products at our trade shows for in this coming year. Also get them in distribution. What do you got here?
Well, I just jumped to the upper end of the XtendedFlex portfolio.
Okay.
This is our 3/8 cable. We call it XF213, and the reason
So this is the largest.
Yes.
Okay.
And you mentioned about some of the other applications,
yes.
And that's why I was just dying to grab this one here. Because this is something we developed for an autonomous subway system.
Oh, neat.
And, the RFID antennas were mounted in the tracks, but they're also mounted on the wheel carriages. So all day long, the cable's being flexed and twisted every time it moves from one track to another or runs a bend.
Okay.
Tough, and had to use a fairly large cable.
Tough environment, too.
Yeah. As we mentioned earlier, as you go to smaller cables, it takes a lot of the strain off the cables. But when you need that kind of loss performance, you need a larger cable. That's a pretty tough thing. They're originally looking for something that would survive a few years. We developed something that would survive 30 years. We actually took the environmental conditions for summer and winter for New York City over a 30-year period, look at historical, run it through an environmental chamber, and had the exact flexure that the tracks would see when they went from track to track. That the customer gave us.
So wait, this is on the New York subway?
This is the New York subway, yeah. Yeah, so it passed that 30-year lifespan. So something really, really, so we have the products, I guess.
Yeah.
Because, in terms of, just closing a loop on that.
It just sounds like we spam the gamut of applications too with this high flex product.
We do, and this is the kind of stuff we love to do.
Well, I know, and I know you love it, and I love seeing your passion, and I thank you for coming as usual. Anything else you need to show us today?
Yeah, one thing I would like to do is, we're always thinking, forward, and as we see some of these high flex applications, we're seeing more and more demanding requirements.
Demanding as far as the flexibility or the tougher environments?
The number of flexes, the bend radius of the flexes, that type of thing. So we have a product here that it's made with our Aerocon product. From our Micro Coax, our sister company, and it's a plated aramid, and it creates a sock. So a lot of times the failure point with a lot of these high flex applications is the shielding. The outer conductor's taking the brunt, and you start to lose shielding effectiveness. At that point, your loss goes up, and you start to you have a problem. with this sock technology, it flexes and flexes and flexes. You're not work hardening, copper or steel.
I was like, let's show that flexibility.
Yeah. And again, it's not just the flexibility, but it's the ability to perform with flexure over time.
Ability to perform over flexure over time. Yep. Got it.
So this is something that's actually developed to survive 20 million flexes.
20 million?
In a robotic arm type application.
Wow. Fantastic. Well, thank you again for coming, Kevin, and talking about XtendedFlex. Always a pleasure.
Yeah, thanks a lot. I love being here.
Thank you. And thank you for watching Real Times. If you have any questions, you can reach out to us at realtimes@timesmicro.com. That's REEL. And until next time, stay real.